Hello, in this video we have this interesting exponential equation. We have 1 to the power of k plus 2 to the power of k equals 4 to the power of k. And we are going to solve for the value of k that satisfies this equation. We have 1 to the power of k plus 2 to the power of k equals, instead of this 4 to the power of k, we can rewrite it as 2 to the power of 2 all to the power of k. Then what we need to do is to consider this identity. If you have a to the power of n all to the power of n, this simply equals a to the power of m all to the power of n. So we are going to apply this identity right here, and we are going to have 1 to the power of k plus 2 to the power of k equals, this we can have 2 to the power of k all to the power of 2. So right now, let's work on where we have 1 to the power of k. So if you have 1 to the power of k and the value of k ranges from 0 till maybe infinity, that means as long as the value of k is between 0 and infinity, the value of 1 to the power of that number will remain 1. So 1 raised to the power of any number between 0 and infinity will give you 1. So because of that, we are simply going to replace 1 raised to the power of k with 1. So that means instead of 1 to the power of k, we are going to have 1 plus 2 to the power of k equals 2 to the power of k all to the power of 2. Then from here, we can decide to say let x equals 2 to the power of k. So that means we are going to have 1 plus x equals x power 2. So we can rearrange this equation. We are going to have x power 2 minus x minus 1, and this equals 0. So this actually becomes a quadratic equation that we are going to solve. And we are going to solve this using the formula method. We have x equals negative b plus or minus the square root of b squared minus 4ac divided by 2 times a. And from this particular equation, we have a equals 1, that is the coefficient of x squared. We have b equals negative 1, that is the coefficient of x, and we have c equals negative 1 as well, which is the constant here. So we are going to insert all these values for a, b, and c in this particular quadratic formula. So we are going to have x equals negative b. We are going to have negative into, we have negative 1. We have plus or minus square root of this. We are going to have negative 1 power 2. We have minus 4 into a, that is 1, and we have times negative 1. And all this is simply, we are going to divide everything by 2 times 1, that is 2. So we have x equals, this will give us 1. We have plus or minus square root of, this will give us 1 as well, and this will give us positive 4. So we have this, and everything here is divided by 2. So let's proceed. That means we are going to have x equals 1 plus or minus root of 5 divided by 2. So we are going to have two values for x. We have x equals 1 plus root of 5 divided by 2, or 1 minus root of 5 divided by 2. Now, the square root of 5 here is greater than 1. So that means this definitely will give us a negative number, because if you subtract this from 1, you are going to have a negative number. And since we are going to have a number that is less than 0, that is a negative number, we are not going to use this particular solution of x. So we are only going to concentrate on when we have the positive value of x, which is 1 plus root of 5 divided by 2. So that is what we are going to concentrate on. That means we are not going to make use of this particular solution. We are only going to make use of this one here. So because of that, we have x equals 1 plus root of 5 divided by 2. And if you recall, let me get us back there. We had x equals, look at it here, 2 to the power of k. So I'm going to get that and make use of it. So we have x equals 2 to the power of k. That means we are going to have 2 to the power of k equals 1 plus root of 5 divided by 2. Have you seen that? So what we are going to do next is we are going to solve for this k. Now we can make use of log. So we can have log of 2 to the power of k equals log of 1 plus root of 5 divided by 2. And in logarithm, if you have log of a power b, this equals b times log of a. So that's what we are going to apply here. That means the k here will come behind and multiply the log. We are going to have k log of 2 equals. Now also, if you have log of a divided by b, this simply equals, we are going to have log of a minus log of b. So if we apply this identity right here, we are going to have log of 1 plus root of 5, then we have minus log of 2. So since we are solving for k, we divide this by log of 2, and we divide the whole of this by log of 2. So because of that, log of 2 here will cancel log of 2 here, and we are going to have k equals log of 1 plus root of 5 minus log of 2, then divided by log of 2. Now, this can be your solution. Then what you need to do is to insert the values of log of 1 plus root of 5. Then you insert the value of log of 2 and you divide it by log of 2. You can make use of your calculator to achieve that. But meanwhile, how I would have solved it is, instead of making use of this log to the base of 10, I will simply make use of natural log. So what I would have done is, I can as well leave my answer as, let me write here, or. Meanwhile, we had log of 2. This is log of, let me copy what we had before. This is log of 2 to the power of k equals, we had log of 1 plus root of 5. Then this is divided by 2, right? This is what we had. Okay. So for me, I will simply, meanwhile, remember this k will come behind. I will have k times log of 2 equals log of 1 plus root of 5 divided by 2. So what I will simply do is I can rewrite this as k is simply equals to log of 1 plus root of 5 divided by 2, and this to the base of, I have 2 here. So this can be another answer. If you don't want to make use of your calculator like this, you can leave it in this form. So that is it for the video. Thank you and goodbye.